n0 greater than or equal. It does not matter. For every n greater than n0, we have fn greater than or equal to c multiplied by gn. And these constants there exist only when the growth of function gn is less than or equal to growth of function f. So if growth of function f growth of function f be greater than growth of function f, we cannot find such constants that this condition satisfies. So this definition and this condition satisfies only when growth of function f is less than or equal to growth of function f. If we draw this notation, we have something like this. Suppose n0 is here. From n0 to infinity, we have c multiplied by gn has less than or equal value to fn. Before this point, before nsf does not matter. After n0 does matter, and from this point to the infinity, the value of fn should be greater than or equal to the value of c multiplied by gn. And it is not possible unless growth of function g be less or equal than growth of function f. For example, if fn be equal 2 multiplied by n plus 5, fn belongs to big omega n, because the growth of function n is less than or equal to growth of function f. Both functions are linear. Fn belongs to big omega log n, because the growth of function log n is less than the growth of function f. So the growth of function log n is a lower bound. Big omega give us a lower bound for the growth of a function. When we say f belongs to big omega log n, we are giving a lower bound log n for the growth of function. We mean that the growth of function f is bigger than or equal than growth of function log n. But fn does not belong to omega n power 2, because this function n power 2 cannot be a lower bound. The growth of this function cannot be a lower bound for the growth of function f. So any function that has a less than or equal growth can be a lower bound for the growth of function f. If we state this concept by limitation, the limit gn divided by fn when n goes to the infinity becomes okay. If the growth of gn is less than the growth of fn, this limitation becomes 0. But the growth of gn may be equal to growth of gn. Then this limitations becomes a constant c, which is not equal to 0. So big omega gives us a lower bound, and Fn belongs to big omega G means that growth of G is less than or equal to growth of Fn. And this notation gives us a lower bound for the a lower bound for a function. Okay, and the last notation, theta notation. Theta notation. This notation is a combination of two previous notations. I mean, Fn belongs to theta gn if and only if Fn belongs to big O gn and Fn belongs to big omega gn. So theta notation gives us an exact growth of a function. When we say Fn belongs to theta gn, this notation means that growth of g is equal to growth of f. These two functions have the same growth. And if we are going to state this definition in a formal way, Fn belongs to theta gn if there exists a constant c1 greater than 0, and there exists a constant c2 greater than 0, and there exists a constant n0 greater than 0, such that for any n greater than or equal to n0, we have Fn less than or equal to c2 multiplied by gn, and Fn is greater than or equal to c1 multiplied by gn. This means that Fn is between two constant factor of g, between c1 gn and c2 gn. The right hand give us big O notation. The left hand gives us big omega notation. Okay, and graphically,
sorry, doctor.
yes.
I have a question.
Yes.
The previous page. The previous question, the previous equation, that means the value from n0 to infinity, or what?
Yes. This I draw the picture in the this slide. This means that from n0 to infinity, the value of Fn must be between two factors of function g. Let's draw it. For example, if Fn is this function, and for example, we have two we have two factor of gn, c2 multiplied by gn and c1 multiplied by gn from n0 to infinity to the infinity. The value of fn must be between the value of cgn and the value of c1gn and the value of c2gn. This definition combines the last definitions of big O and big omega. If we consider that fn is the value of fn is greater than c1 gn, this is the big omega notation, and if we consider the value of fn is less than or equal to the value of c2 gn, this is the big O notation. So we have both big O notation and big omega notation. Theta is equal to big O and big omega in the same time. So let's give you an example. For example, if fn be 2n plus 5, this is belonging to theta n, because the growth of function n and the growth of function f, which is 2n plus 5, is the same. Both functions are linear functions of n, and both functions are of power 1. And in both functions has power 1. But function f does not belong to theta n2, also does not belong to theta log n, because function n power 2, the growth of function n power 2 is not equal to the growth of function f.
Sorry, doctor.
Okay.
This logarithm for what basic? 2 or 10?
Okay. When we are speaking, when we are talking about growth of functions, the base of the logarithm does not matter. Why? Because log n in base of a equals to log b in base of a multiplied by log n in base of b. This means that this term is a constant.
Okay. That means we deal with many type of numerical of data. That's it?
So if I give your point correctly, this means log n belongs to log n in base of a belongs to theta log n in base of b. Okay, both functions have the same growth because one of them is a constant multiplication of the other. Okay.
Okay, that's clear. Thank you.
Okay. So we do not mention the base of the logarithm. We can consider by default it is 2. Okay. We finished the lecture. If there is any question, please let me know. Otherwise, I say you fi amanillah.
Thank you, Doctor.
Thank you,
very much.
Doctor.
Thank you for your help.
Thank you for your help,
Thank you,
Doctor.
Doctor. Thank you very much.
Thank you very much.